Now let's review some examples for part 2 of the review and slash assessment, error analysis, and create your own problem questions. Now let's review some of the error analysis type questions you may see on your test. The question is phrased that a student factored the given quadratic expression. Their answer is in red. Is their answer correct? Why or why not? If their answer is incorrect, fix their mistake. Now, based on what we've learned through this unit, we know that the two numbers they pick should multiply to the last number and add to the middle number. And we see here that we have 6 and 4. And if we check, 6 times 4 gives us 24. So that works. But 6 plus 4 gives us 10, not 11. So this does not work. So you would say in this case, the student is incorrect. 6 times 4 equals 24, but 6 plus 4 doesn't equal 11. The second part is you need to, if it's incorrect, fix their answer. So with the two correct numbers that would multiply 24 and add to 11 would be 3 and 8. So you would then have to say the correct answer is x plus 3, x plus 8. You need to make sure in these types of problems that you use specific evidence, such as saying 6 times 4 equals 24 and 6 plus 4 doesn't equal 11. If you don't include concrete evidence like this, you will not get full credit for the explanation. Just saying it's correct because it's correct doesn't satisfy the explanation that's needed. In the next problem, we can see that the first thing they should have done is take out a greatest common factor. So if I divide everything by 4, it gives me 4p squared plus 3p, and then if I do 72 divided by 4, it gives me minus 18. So I need what two numbers multiply to negative 18 and add to 3. And if I check, I have 3 and negative 6. Now when I check those numbers, I have 3 times negative 6 gives me negative 18, which is correct. And then 3 plus negative 6 gives me negative 3. However, this should be a positive 3, so this would be incorrect. So we would say the student is incorrect. 3 times 6 multiplies to negative 18, but doesn't add to 3. The correct answer flips the signs to 4 times p minus 3, p plus 6. For the next problem, we first want to say what our greatest common factor is, and they both have a greatest common factor of 5x. When I take this out, I'm left with 5x, x, and 10. So the student was correct. So you would say the student is correct. After removing a GCF of 5x, there is no need to continue factoring. Now let's review how you would set up some of the create your own question problems. In these types of problems, you have to fill in the blank to create a quadratic you can solve by factoring. Then you'd solve the quadratic. Now, what we know is we always needed to multiply to the last number and add to the middle number. And you're filling those in to your blanks. Now, the way you can do this is you can pick any two numbers that add to positive 3. So if I decide to choose 1 and 2, because we know 1 plus 2 equals 3, I would have to say that 1 times 2 equals 2. So the number I would fill in would be this 2. So I would fill in plus 2, because I decided to use 1 and 2. So plus 1 plus 2. Now I'm going to finish solving. So to do this, I would say, okay, I have x plus 1 equals 0, so I get x equals negative 1, and x plus 2 equals 0, so I get x equals negative 2. So your answers are negative 1 and negative 2. But again, your answers will vary for this problem. In this example, now we want to solve, and again, we know that it always has to multiply to the last number and add to the middle number. And we're filling those in to the blanks. Now, we can choose any two numbers that multiply to 12. So if I want to do this, let's say I decide to use negative 3 times negative 4 gives me 12. I could also have negative 3 plus negative 4 gives me negative 7. So I would have to fill in this negative 7 here. But again, we know it has to have a variable, so minus 7n. And these numbers I'm going to fill in to the blanks. So I'll have minus 3, minus 4. Then I would finish solving like I would any problem. So we have n minus 3 equals 0, so I get n equals 3, and n minus 4 equals 0, I get n equals 4. So again, while your answers really may vary, it's all based on the fact that you're choosing two numbers that multiply to 12.